So, okay, hold that thought. Welcome, everybody. This is the June meeting of the West Michigan Azure User Group. Thank you all for coming. Thank you for our speakers and our sponsors for helping us out, and our organizers for all their commitment to this technology. We've got a great session today. We'll get to that in a second. But yes, so typically we meet on every second Tuesday of the month. Broad topic when you say Azure as a user group, but we try to mix up a little bit. We try to hit a little infrastructure. We try to hit a little application dev, DevOps, security, naming, best practices. So hopefully it's a global topic enough for anyone who can learn something new about Azure. And if there's any topics of any of the attendees that they'd like to see future presentations on, please let me know. We're always looking for more and more topics to talk about. And we are actually set for topics for the next couple months. As Kim just mentioned, one of the very next things we're going to do in July is a build recap. So in case you don't know, Microsoft Build is a very large conference where a lot of announcements happen on the Microsoft product line, especially around Azure and Visual Studio and just .NET and all sorts of fun things that Microsoft does. We've got a big book of news that we can share and cover those highlights. It's probably going to be a co-presentation from a couple of us for people who specialize in those areas. And excitedly, it's actually going to be at Spartan Innovations. So new location for us. That is more downtown-ish. Not too far right here is what Kim is saying. But we'll put instructions on the Meetup page for sure. And we're going to try to do a little something to go with it. I'll just leave it at that. We're figuring that out. Could be some fun things to eat or drink. I'll give that much away. So please come next month as well. I think we're set from an official recording standpoint. I got more of a thumbs up. So I will then kick off our session today. Of course, I had the thing up and ready, and I lost it. So I'm just going to do it off the top of my head because this is actually my good friend, Jay Tower. Jay is here in West Michigan, and he is one of the founders of Trailhead Technology Partners. They've been in business for many, many years now. I don't know the number of years. 8 years. Global company, actually, distributed, and they build a lot of applications and mobile apps and other technology solutions for lots of companies that they deal with. And Jay actually happens to be a well-known national speaker. He's been speaking for forever, I feel like. And he has over 25 years of experience in this field. When we talk about development and IT solutions and all sorts of technology things, he happens to also be a Microsoft MVP. So he knows a crap ton about developer tools and Azure and other things. And I'm excited for him to talk about his presentation today. So I'll let him introduce that. But please give me a nice round of applause for our speaker, Jonathan Tower.
All right, thanks everybody. Let me get my mic situated here. Matt, can you pick me up on that all right? All right, cool. Hey everybody, nice to see you all. Hopefully you can see the slides okay here at a bit of an angle. I suppose if you feel like you want to see something better, feel free to walk over here into the kitchen area at some point while we're talking too. I'll either think you're trying to get a better picture of the slides or that you're hungry. Either way, it's fine. So we're going to talk about not building a distributed monolith, but how to avoid doing microservices completely wrong. So I want to start with a story. A client of ours came to us about a year ago now and said, hey, we've got this microservices application that we're just about finished building. It's just about to launch. And it's got a few little performance problems. We're wondering if you can help us tune up a few of the backend APIs, a few of the endpoints are kind of slow with their database connectivity, some things like that. We're wondering if you can kind of help us get that stuff squared away before we launch really quick. Sounded like a totally legitimate request, so of course we said, yeah, sure, we'll take a look at it. Well, it did not take long looking at their code and looking at their architecture to realize that what they needed was not a small amount of little tweaking. What they needed was to completely re-architect their application and rewrite it. And I'm not just saying that because I'm a consultant and we have this track record of always saying you should rewrite everything, but because they had not built microservices as they thought they had. What they had actually built was something called a distributed monolith. And this is the bad guy in our story tonight. So We're going to be talking about this term. If you haven't heard that term before, maybe you have, but you don't know exactly what it means, we're going to talk a little bit more about what that means and what makes that different from a monolith or microservices. So my goal tonight is to basically give you the 10 most common problems that I see as I'm working with our clients, many of whom have started out their own microservices application. When we get involved in the project, we see, all these legacy decisions that have been made, and in a lot of cases, they've made mistakes that have caused this to not be really microservices, but to be this distributed monolith monster that we want to talk about tonight. So that's my goal tonight, is to walk you through the 10 most common mistakes that I see to help you avoid making those same mistakes if you're building a monolith, whether it's on Azure or something else. I'm sorry, microservices on Azure or something else. A little bit about me. Brian kind of did a nice intro already, but if you want to get in touch with me, these are places that you can do that. I also offer this free consultation in any of my talks. Basically, I'll be available here for questions if you want to come up afterwards, if you want to raise your hand at the end. That's all fine. Sometimes people don't feel comfortable. Maybe there's something proprietary, or maybe they're embarrassed about some architectural decision that was made on their team. They don't want to admit it in public. Any of those things, if you want to reach out to me, you can do so at my email address here, or you can sign up for this free consultation, and basically that'll give you an email with the ability to schedule a little bit of my time, and we'll meet online and we'll figure out what's going on. Also at the bottom of the slide is a link, which I'll show all of this information again at the end. That link is to the GitHub that has these slides, if you want to check those out. I'd be remiss if I didn't also mention to a bunch of people who are interested in talking about distributed monoliths and microservices that there's a software conference that I happen to be the lead organizer of that's coming up in town this summer. Beginning of August. It's called Beer City Code. If you want to check it out, tickets are on sale right now. Actually, the pre-sale is going on right now, which means that you get the best price. In just about 3 weeks, that price is going to go up. So beercitycode.com if you want to check that out. I know there's a lot of people here that I know who've been there before or have been involved before. So love to see the rest of you all there. All right, so let's start out the talk with some definitions. Before we get into a lot of the details, before I get into my list of 10 things, I want to just make sure we're all on the same page. So what do I mean when I say microservices? What do I mean when I say distributed monolith or monolith? So let's start with the monolith. This is the one that we're probably, if you're in the software industry at all, you're probably familiar with this already. This is kind of the traditional model for building large applications. In a monolith, you've got the different parts of your application. They all have to be present for the application to build. They all have to be present for it to deploy. Typically, the advantages of this are that it's much easier to build than microservices. It's also much better with something called data latency, which I'm going to talk about more in the talk as we go. So just to make sure that I'm not confusing you, though, when I say data latency, I mean something different than when I say scalability or speed, okay? So we'll talk about the distinction between those as we're going. Typically, they are scalable, right? We've all probably scaled a monolithic application before. You can do things like putting it on a bigger server with more memory, with more processor, multiple servers, multiple databases, all of these types of things that you can do to scale a monolith. But it's maybe a little less scalable or a little less flexibly scalable than microservices. There's also fewer cross-cutting concerns. We're going to talk about that as we get into it. And it has this advantage that's called immediate consistency. We'll talk a lot about that tonight. Disadvantages. One of the disadvantages is that if you want to make even the smallest change to your application, you have to change the whole thing. We've all seen this before. If you've been working on a monolithic application, someone wants to change some text, or the text on a button or something like that. Okay, well, it's an entire application deployment, which means the whole thing has to come down, which means that button can't change until later in the evening or on the weekend or whatever the schedule is for your particular application, right? That's a downside to a monolithic application. Not quite as agile. as microservices. Microservices allow you to be pretty agile. You can still do agile development for sure on a monolith. It's just not quite as flexible with how you do your agile processes. Obviously, there's going to be some tight coupling between the modules in your monolithic application. That could be a disadvantage. And then it really does not easily allow for small teams that are focused on very specific areas of the business, which is something that microservices does very well. So if you're looking for that type of, this team focuses on this team focuses on that, there's enough of that stuff that crosses over into these cross-cutting concerns when you're doing a monolith that it's hard to split your team up that way. Typical monolith is going to architecturally look something like this. You're going to have multiple clients that are connecting into some sort of a middle tier or application layer, probably some sort of a data store. Like I said, you can scale a monolithic application. You can obviously scale the middle tier by scaling it vertically, which is what you would call it in something like Azure or AWS if you were basically adding more processor, more memory, more storage to an existing server, virtual machine, instance, whatever. You can also scale the database. You can scale the database the same way vertically by adding more resources to the database. You can also obviously scale these what's called horizontal scaling, which allows you to do things like load balancing. So if you have a web application, you can take those web servers and create multiple copies of it, put a network appliance called a load balancer in front of it, and basically split the traffic up between those. A lot of this stuff happens automatically in Azure, right? If you do app services or something like that, that type of thing can happen for you automatically. It's kind of built in free of charge. You can also do the same thing with your database. If you have multiple databases, whether it's relational or whether it's a more modern like document database or NoSQL database, you can do something called data sharding on either of those, where you basically take your data and you divvy it out to different database instances. Maybe it's by tenant or by client or by user or something like that, so that your data is kind of separated out or sharded out into different instances, and that allows you to spread all of your querying and updating load between those different instances. Okay, so that is a totally valid architecture, a monolith. There's also this concept that monoliths come in a couple of different varieties, and everything falls in a spectrum between these two extremes when you're building a monolith, right? There's basically a well-designed monolith and a poorly designed monolith. I'm guessing if all of you have been doing software development for very long, you've probably seen, to some degree, you've seen both of these in your experience. I certainly have. The ball of mud monolith, just to kind of give you an idea of what that looks like. This is the one where, this is the type of application where when you go make a change and you fix one thing, it breaks 6 other things without you knowing it, right? You've done that. I'm sure you've seen those types of apps before. Now, a well-designed monolith is going to be much more modular. If you're going into one place to change one thing, you're going to know you're just changing that one thing. You're going to know exactly what you need to test. You're going to not have a very high probability of breaking anything in other areas, right? So you've got kind of this spectrum when you're building a monolith. Is it modular, or is it kind of a ball of mud where everything is connected to everything else? So that's our monoliths. Let's talk now about what is a microservice. So there's a very interesting definition that Google actually uses for their microservices architecture, and I'm going to read it to you. They say it's a architectural and organizational approach to software development where software is composed of small, loosely coupled services which communicate with each other using well-defined messages and are owned by small, self-contained teams. So anything stand out to anybody in that definition as being a little surprising to be in a software architecture definition? Team structure, yes. Yeah, so there's actually 2 mentions. It's mentions at the beginning of the definition an organizational approach, and it also mentions a team structure at the end, right? Those 2 things kind of surprised me when I first read this too, when I was first learning about microservices. But I think that's a really important point. Microservices are an architecture, but they're also a team organization or team structure that applies to how you do things as well. So The important part, though, the part that you're probably already familiar with microservices, is these small, independent services that can be deployed separately, can be built separately, can be built by separate teams, and have really no direct connection with each other, but are able to communicate with each other through what this definition calls well-defined messages. So we'll talk about what that looks like here in just a second. Benefits: independently deployable. I was in a talk with an Amazon DevOps person who was responsible for DevOps for Amazon.com, the e-commerce part of the site. And this was quite a few years ago now, but at the time they were saying there was 10,000 updates to Amazon.com a day through DevOps. All right, so that is not possible in a monolith, right? That's your monolith, and your build only takes a few seconds. Your monolith is still down basically all day if it's getting updated 10,000 times. So Amazon.com, not a monolith, obviously. They want to be able to update different parts of the app and have other parts of the app totally unaffected by that. You've probably seen the statistics. If it takes an extra second for the Amazon.com front page to load, they lose like $1 million every minute or something like that, right? So they do not want their website going down 10,000 times a day, let alone even just once a day. So independently deployable, that means all these different parts of the application can go live and be updated totally independent of each other. Precision scalability, let's say you have a flight search application that allows people to, maybe they can log in, they can save their trip information, they can add payment methods, they can also search for flights, but searching for flights is like 90% of the usage of your application. Well, precision scalability means that that particular microservice that handles flight search can have all kinds of resources behind it, while maybe your account management services have very few resources associated with them. So that precision scalability is a definite advantage. High availability. The whole idea of microservices is the ability to not only deploy these modules separately from each other, but to be able to do it in such a way that if something goes wrong with one, that it has no impact whatsoever on the others. Also, the way that that's done is through loose coupling. So that's kind of an advantage when you're trying to make changes to one application. One part of the application, having it loosely coupled with other parts makes that easier. One that people don't think about very often that's an advantage is the ability to use different tech stacks. So you imagine a really large company that has a really large application with many, many different teams that are working on it, maybe hundreds and hundreds of developers that are working on it, like Amazon.com. You might have parts of that application that are built in PHP, and parts of it that are built in Python, and parts of it that are built in Java, other parts of it that are built in .NET for whatever maybe systems they're integrating with, maybe whatever is the technology of choice of those particular teams. Microservices allow you to do that. You can have totally separate tech stacks for each of your services because they are loosely coupled to each other. I mentioned before, it allows more agile processes and smaller teams that are more focused on very specific parts of your business. There are disadvantages, of course. It does require a complete reorganization of your team, going back to that Google definition. If you don't reorganize your team to fit microservices, then you will end up building a distributed monolith, most likely. Debugging and monitoring is way harder in a distributed application than it is in a monolith. And maybe the biggest disadvantage of microservices is that they're very difficult to do correctly. As a consultant, I get involved in a lot of projects that have already been started, and I would say maybe 1 out of 100 microservices projects were designed well, the ones that I see. Meaning that 99% of the time, and that's just my anecdotal experience, but something well over 90% of the time, people are making mistakes that make a very poor performing application because it's just so hard to do them correctly. And then the last one, which I want to really emphasize, is something called eventual consistency. I talked about immediate consistency when I was talking about a monolith, and I mentioned that as something that we're going to cover more, which we will. But I want you to start thinking about this eventual versus immediate consistency thing, because this is an important distinction between microservices and monolithic applications. What does a microservice look like? This is a typical architecture for a microservices application. You have a bunch of clients. There's usually some layer in there. In Azure, this would be the Azure API Gateway Service. If anybody familiar with that one, use that one at all? It's very common to bring all of your APIs together. A lot of times security would be implemented in this layer as an example, since that's a cross-cutting concern. And then you've got each of your microservices is kind of like one of these pillars here. Now, importantly, you'll notice that each of these has its own application and its own data store. In this case, it's a database. That's an important distinction as well. And then at the very bottom of this diagram, you see there's an event bus. Azure has an event bus. Actually, Azure has like 3 event buses, depending on how you count it. But there's one that's actually called event bus, I think, right? Yeah, there's one that's actually called event bus. There's also a messaging queue and an event grid, I think is the name of the other one. Anybody remember? Does that sound right? Okay. Yes, exactly. Thank you. So this event bus here is basically a back channel with these well-known events that I mentioned earlier in my Google definition, that these microservices are able to basically do a publish and subscribe type communication with each other. We'll talk more about that as we're going into it. All right, so the last type of application you can build, the bad guy in our story tonight, is this distributed monolith. You might have already picked up what this is. This is basically when you set out to build microservices, but then you make one of these mistakes, and instead you create something that is still highly coupled. All the services are highly coupled to each other, but they're distributed separately. So you can imagine something that looks, and by the way, we don't want to do this. This is what we're trying to avoid, right? You might recognize this part of this diagram from my microservices architectural diagram. And that's because nobody sets out to build, hopefully, nobody sets out to build a distributed monolith. It happens by accident 100% of the time. But when you set out to do it, you're actually usually setting out to do microservices. And so there'll be some form of this architectural diagram, but then the problem comes in with all these red arrows, which I purposely drew in here to look haphazard so that you would know that they're a mistake, okay? All of these arrows where applications are talking directly to each other or they're talking to each other's databases are, in fact, mistakes. Even if you add that event bus layer so it looks almost exactly like our microservices architecture, but still leave in all those red arrows, you still have some significant problems. Those red arrows basically represent direct communications between applications, which means coupling. And if you're trying to build microservices, you're trying to minimize the coupling between your applications. I'm going to give you lots of examples of how these are going to cause you problems as we go. But this is the visual I'd love you to walk away with. If you're thinking about building something with microservices, I'd like you to think about these red arrows as the problem. When you're creating your own architectural diagram, you can know that you want to avoid those. Here's another very popular way to do microservices completely wrong and to make a distributed monolith. Usually when I show this slide, I see a few smiles in the audience, and I make a point of trying not to point anybody out, just because usually that smile means you recognize this, maybe from your own organization or an application that you're currently working on. This is a very common mistake, and I'll tell you why this always happens, because database administrators or database developers have it beat into their heads from the very beginning that you don't repeat yourself, you don't copy data into multiple places, you normalize it, right? This is at the very foundational layer of what it means to be a good database person, a good database designer and implementer. And when a bunch of people start coming in and saying, each part of the application is going to have its own database, which means we're going to need to copy some data around between them through this event bus. Most database people who haven't seen this architecture, aren't familiar with it before, are going to immediately have all kinds of red flags and say well, look, all you mid-tier developers can do whatever you want with your mid-tier part of the application. You can make that as microservice-y as you want. but you're not going to split my database up and denormalize it into all kinds of different databases that are having to keep in sync with each other. I don't know much about what you guys do, but I know that's a bad idea, so I'm not going to let you do it. Right? So that happens a lot, and that's, I think, where you mostly see this architecture come from. I'll talk about this more in my 10 examples and how this causes you problems. Okay, so we've talked about basically the 4 different kinds of applications that you can build when it comes to microservices versus monoliths. If you build a monolith, you can build it as a ball of mud, which is basically a poorly designed, highly coupled, more fragile application, or you can build it as a more modular monolith. Hopefully, we've all had experience working on some of these more modular monoliths, and you know what a joy those can be to maintain, even though they do have some of the downsides of a monolith. You want to change the name of a button, you need to update the whole application, right? And then we also talked about we talked about true microservices, it does show up pretty good on there. True microservices, and then this distributed monolith. And I've graphed them out for you here. Hopefully from your angle you can see this okay, but I've graphed them basically on how logically modular they are and how physically distributed they are. So if you take in the top left corner there, the distributed monolith, that's our bad guy. That is where you take a logically monolithic application, meaning there's a lot of coupling between the modules, but you deploy it separately. Okay, so at its core, that's what you're trying to avoid doing. You're trying to avoid building something like it's a monolith and then deploying it separately as if that will somehow make things better. That actually makes things worse than if you just built it as a monolith. You've got this ball of mud monolith where it's physically deployed as a single thing, but it's also very logically highly coupled. So it's very difficult to change one thing without breaking several other things. If you make that more modular here logically, but still deploy it as a single thing, now you've got your modular monolith. And then in the top right corner, if it's 100% modular and deployed separately, that's where you get your true microservices. So you can see how if you have experience building these and you're trying to aim at this, how you would end up here, right? Okay, so that's kind of getting on the same page. Hopefully that helped everybody understand what I'm talking about when I talk about those terms. Now let's talk about these 10 most common mistakes that I see when people are building microservices and end up building distributed monoliths. So number 1 is something that hopefully isn't a surprise to you based on what I've been saying so far, which is the mistake of assuming that a microservices architecture is always going to be better for you. There are a lot of ways that you can tell whether you really need microservices, but I always ask people to keep these things in mind. Number 1, monoliths aren't always bad. There are some applications where monolith is a really fantastic fit. Number 2, microservices are really hard to do well. If you have a team that's never built, no one on the team has ever built microservices successfully before, and you also don't feel like the application that you're trying to build has a lot of demand built into it for the advantages of microservices, right there you can already probably tell that that's a bad fit. So I mentioned earlier the free consultations that I offer. I have a video version of this talk that went live recently and has been seen by hundreds, probably tens of thousands of people. And so I've gotten a ton of people coming into that meeting. The number 1 topic that they're coming into those meetings with is basically like, we have a single team building an application for 100 users to use internally, and nobody's ever done microservices before, and it's not going to ever really need to scale above that. Should we do that as microservices? And those are really short meetings, because I can just say, no, you don't have a single reason in that list that you should actually build a microservice. The last thing is that when you have a wrong reason, which are these next 9 that we're going to be talking about, when you have a wrong reason, and that's maybe your only or your main reason for building microservices, you're going to almost certainly build a distributed monolith and be really sorry that you tried to do microservices. So I don't want to poo-poo microservices completely. It's a really fantastic architecture. Hopefully you didn't come here thinking, I'd really like to learn more about microservices, and now I've just been talking bad about them the whole time. Really what I want you to walk away with is knowing that microservices are good for some things, monoliths are good for some things, and I want you to walk away with knowing which is which and when to do each of those. Some good reasons to do microservices. James Lewis wrote a book about microservices, and he said that microservice architectures buys you options. So if you need to do scalability, if you need that as an option, if you need independent deployability, or if you need to isolate the surface area of failure. What do I mean by that? Basically, I mean, if one part of the application goes down, it won't bring any other part of the application down. So if you had a reservation taking system or Amazon.com, to use my example earlier, you want to be able to maybe take some risks in some parts of the application without having any risk of bringing down the part that's actually making your company money. So if any of these ring true for an application that you need to build, it needs to be able to be highly scalable. It needs to go up and down in scalability. Different parts of the application need to scale separately from others. It needs to be independently deployable. You need to do something like that 10,000 Amazon updates a day or something. Or if you need to be able to isolate failures from different parts of the application and guarantee that one part works while another part doesn't, those are good reasons. So the train is here just at the right time to underscore what I think is the most important slide in this talk, which is, if you ask an engineer, if you ask a decent engineer who's been doing it for very long, any technical question, the answer will always be, it depends, right? That's kind of a joke about us engineers. Somewhat true, and it's somewhat based in a reality, which is that everything in engineering is a trade-off. If you want to have an electric vehicle that has 1,000 miles of range, it's probably going to weigh 10 tons, right? Because the batteries are really heavy. And everything like that is a trade-off. So the trade-offs that we're talking about in the monolith versus microservices decision is these things: high availability versus immediate consistency. So if you're looking for like the one thing that will help you decide whether you're going to do microservices or a monolith, this is the question to ask. Do I need high availability or immediate consistency? What do I mean by these things? High availability is kind of what we were talking about before with a failure in one part of your application isn't going to impact another one. It's the ability to deploy independent parts of your application separately. All of that is high availability. Immediate consistency is that data latency that I was referring to earlier. So this is basically where when your application receives a piece of data, how long does it take for the whole application to know that that data has been updated? So imagine someone comes into your application and changes their shipping address. If you have a monolith, how long does it take for the whole application to know that there's a new shipping address for that customer? Anybody? Yeah, but yes, milliseconds if you count the database update time, right? 0 if you don't count that. When you're talking about a distributed system like microservices, immediate consistency is not possible because all of these different independent applications, to be independent from each other, to not be coupled to each other, means that they actually have to have separate copies of the data, which means that if you want to be able to do a bank transaction, for example, where you debit from one account and you deposit into another, and you want to do that simultaneously as a transaction, you can do that in microservices. It's not inherent to microservices that that's going to be a really good fit, especially if those are two different services from each other. Now, if those are the same service, you can think about doing a transaction of some kind within one service. But if that's two separate services, there's going to automatically be some sort of in-between time that could vary depending on how busy the application is, where the whole application is not going to know about that data being updated yet. Okay, so that's why this is the most important one and why I'm so glad the train helped me underscore that. So problem number 2 is shared data or shared data models. So I promised I would explain this architectural diagram a little bit more and why this is a problem. So imagine you've got some different services. Service 1 over here on the left is making a change to this database here and basically saying, you know, I need to actually change the schema of that database table. But it turns out, nobody realized it, but Service 5 was actually using that because there was miscommunication or something, and Service 1 team thought they owned that table, and Service 5 team thought they owned that table. Well, Service 1 team just made an independent deployment of their application, went home and went to bed happy thinking, we're a microservices team, we just did an independent deployment, right? What they didn't realize is that Team 5 is running around with their hair on fire because somebody broke their part of the application and they have no idea why. So are these two parts of the application, even though they look separate, are they actually separate if they're sharing the same database? And the answer, of course, is no, they are not separate. Another example is using the same data model object. So this is very hard to get your head around if you've been doing monolithic development for a long time. But if you created all these microservices projects, you created them in a single Git repository, and probably the first thing you would do would be to create some sort of a reusable project. I'm a .NET person, so maybe you would create like a project file, or you'd create a NuGet package or something like that that's reusable. You'd put all of your models that were going to be the same in all these different applications in one place, and everybody would share the same thing, right? That would make a lot of sense. If you're doing microservices, you don't want to do that because let's imagine this scenario where I've got a hotel, okay? I've got a hotel, it's got 5 different services here, a few of which I've named: reservations, maintenance, and housekeeping. And they all care about hotel rooms. They're all interested in hotel rooms. Now, typically, hotel room in a monolithic application, that's a single database table, right? Because your database person says, normalize that data, only put it in one place. But it's going to have things like, is it currently occupied? How many beds are in it? How long does it take to clean it? Maybe there'll be like a child entity that's related to it, that's like maintenance events that have happened over the history of that particular room. Well, if you're doing a microservices application, sharing this is going to be quite problematic for the same reason. Let's say that the housekeeping team said, you know, we don't really care to a float level of detail how many minutes it takes to clean a room. We just care in like even numbers of minutes. So we're gonna independently deploy an update to the application that says, let's change that float to an int. Well, they changed that, and it's in a shared project that all these other projects reference. Now it doesn't. This model doesn't represent what's maybe in their data store anymore. Now their applications just broke. So again, are these applications really independent from each other if they share this model object? And the answer, of course, is no. The right way to do that, you might be thinking already, like, okay, well, how are you supposed to do this in microservices then, Jay? If you keep telling us what not to do, but what should we do? Well, this is like a more typical model for a microservices application, to have each part of the application have its own data store, to have its own model that represents its data store, and to own the data that belongs to that particular part of the application. So what do you do when there's a piece of the, because this is a nice, perfect example. I've left out anything that is shared between all of them, right? Perfect, like, example where here. What about room number, just as an example, right? Maybe that popped into your head. What about room number? Everybody cares about the room number. How's that supposed to work if the room numbers get renumbered or something like that? Well, let's add another service there in the second position, call it like the admin service. So that way when a new wing of the hotel is built and they're going to add a bunch of rooms, someone can go into the admin module and they can add those rooms into the system. So when they add those rooms, they're going to, of course, use a model that's for a hotel room, and they're going to give it a new room number. What you would typically do in a microservices application is you would then publish an event to your event bus that would say, there's a change or an addition, in this case, to a hotel room. And anybody that wanted to subscribe to that could, which all of our services in this case would care about that, because all of the services that we've talked about so far care about the room number. So all of them would be subscribed to that particular event and would say, I want to update my own data to add a new room to my copy of the data. So now the maintenance database, the housekeeping database, and the reservations service are all going to have their own copy of that they create in response to that event happening from the admin service. So that's the proper way to do it, which you can see is not immediately consistent. In fact, if what you want to do is, as the user, is go in and put in the new room and then immediately go schedule housekeeping to go clean it or something, you might have to wait a few seconds. If the system is really busy and it's taking a few seconds for that to synchronize over there, that's not going to be possible for a microservices application to do that. All right. Yes.
What would you see as the way to populate that from admin to other places, or because it's more than just the monolith, it's the data itself too.
Yep. Yeah, so one of the things you have to have some metadata in a microservice, which is basically every field in your data store has to be marked as whether it's owned by this database or not. So in this case, the room number is owned by the admin one. That's the one that's allowed to create new rooms or renumber rooms or something like that. All the other ones are just basically listening to that event and updating their own. So if you renumbered a room in this one, it would basically publish like a room change event that would say room number 123 was renumbered to 124. And all of these would say, oh, I know about 123. I'll renumber mine to 124 as well. So that metadata is something that's important, is who owns each of these things. Does that answer your question, Brian?
Maybe keep going. What happens when the hotel is in the building and it needs to be like A1, 2, 3, 4?
Yeah, great question. Yeah, so for those that are watching the video or streaming this, the question was basically, what do you do if it's like a major change, like everything gets renumbered to have an A in front of it or something? And yeah, I mean, you would basically have to publish a whole bunch of events to the event bus, right? If you're doing bulk updates, it's going to be a little bit slower in a microservice than it's going to be in a monolithic application. Typical monolith application, you'd probably take it down on a weekend at 2 in the morning or something like that. You'd renumber everything and then bring it back up and send an email out that says, okay, it's working again. Microservice, you would have to do that and then wait for that event to clear, event queue to clear and tell everybody, okay, all the rooms have been renumbered. So a little messier for sure. Okay, problem number 3, microservices that are too big. I'm going to assume, if we have mostly software folks in the room, that you've heard of domain-driven design or DDD before. If you haven't, I have a book recommendation on the next slide. This could be a whole, probably like 5-hour talk just itself. DDD is very complicated, but it's a really great way at figuring out where to split the lines between your different microservices. So it has these concepts called domains, subdomains, and bounded contexts. Often bounded contexts and subdomains end up being the same thing, but not always. If you don't know DDD and you're thinking about doing a microservice, I would highly recommend you learn DDD, because it's going to help you get a lot better at drawing those lines between things. If you're wanting to do that, this domain-driven design book here by Eric Evans is a really good starting point for it. If you don't know DDD, don't worry. The rest of this is not going to be totally lost on you. I have a simple rule, which is basically, if you're trying to create a microservice, you want to create the smallest possible microservice without creating chatty communications between your services. So you want to adjust the dial until the service is as small as it can be without creating lots and lots of events, or worse, those red arrows that we were looking at earlier, between your different services. I have a diagram that shows you what that looks like. But first, I want to mention problem number 4, which is microservices that are too small. So this is just adjusting that dial too far the other way. Great example of this. They're called microservices, right? So one thing I've seen people do before is basically say, well, like, what's microer than doing one endpoint per service, right? Doesn't get any microer than that. We're microing the hell out of these services. So what the problem with that, maybe it's obvious to you at this point already, the problem with that is that creates a lot of chatting between these services, right? These services have to update each other about everything they do. Their whole purpose for existing is to basically communicate what they're doing to each other. Now that basically creates a really inefficient situation where they're always having to wait, and your immediate consistency becomes like a even less immediate consistency. So imagine, you get all this chat between, in this example, a user login endpoint and a password reset endpoint. If you're going to reset the password, or if you're going to say someone who's failed a certain number of times to log in successfully has to reset their password, right? These services are going to have to talk to each other about everything that they're doing. And it's going to be really inefficient to have them separate and to have them having to copy their data between each other and all that. Not to mention, a little insecure if people are failing to log in here and it's taking a few minutes for those failed login counts to go over here to say that they have to actually reset their password, right? These are probably not a good candidate to be separate services, but to be the same service. So this is the diagram I talked about, very similar to my trade-off diagram before about monoliths versus microservices in general. But basically, do you want your service to be small? If you do, the smaller you get, it's the chattier it's going to have to be, right? Do you want it to be really big? Well, it's not really microservices. If you go infinitely big on basically up to 1, it's a monolith now, right? But it's not going to be very chatty anymore. So where do you want to set it? Well, somewhere pretty close to the middle, basically. So that's kind of my rule of thumb that I think gets at what domain-driven design helps you to decide. It's not a very scientific way of thinking about it, but it is, I think, accurate. And it does apply to all situations. So basically, if you find yourself thinking like, boy, this service and this service are starting to chat with each other an awful lot, maybe it's time to ask the question, should these actually be separate services or not? Or if you have the opposite problem, like, gosh, it seems like this one service is doing an awful lot of unrelated things, maybe that should actually be separated out. If you could do it without creating lots of chatting between them, then you're probably making a good decision. Problem number 5, starting from scratch. Nobody who is a software engineer prefers brownfield projects to greenfield projects, right? Everybody agrees that greenfield is better because you get to make all the architectural decisions and that are later going to be hated by everyone who's maintaining the application, as opposed to someone else in the past having made those terrible architectural decisions. I want to make my own mistakes, right? But in this case, a brownfield project has some pretty significant advantages if you're talking about microservices. I've listed a few of them here. Number 1, the code actually documents the relationships between the different parts of your application. So you can actually see this thing and this thing have a really strong relationship. There's a foreign key between them in the database. And every time this thing is updated, this other thing is updated too. Whenever I delete one of these, I have to delete one of those as well, right? The code documents all of that for you. Another thing developers hate is writing documentation. So maybe the code is the only documentation. And if that's the case, you actually have something that tells you this is how this application works. Here's where the relationships are in this different parts of this application. It actually gives you clues for where to draw those lines between different services. Number 2, maybe there's people who actually built this. This isn't always true, but maybe there's actually people who built that application who can tell you why they decided to do things the way they did. Every time I start on a brownfield project, there's all the engineers are complaining about the decisions other people made before. Oh, this is so stupid. I can't believe they did it this way. Usually a few months later, everyone's like a little more nuanced about it, right? Like, oh, I can see why they did it that way. It was a trade-off. It would have been really hard to do it the other way. And so now you've actually, hopefully, if you've got an existing project, you also hopefully have an existing team that you can refer to for why things were done that way. And you can maybe save yourself some of those same mistakes again. Number 3, system that already works. What's great about this is it buys you time, right? You're trying to create a microservice project. Maybe it's the first one you ever did. Maybe your boss thinks that there should be some sort of deadline associated with the work that you're doing, that it should eventually go live and people should be using it. Well, if you are under the gun and there is no system that's doing the things that you're writing because you've basically taken it down or it didn't exist before, then that deadline is kind of a significant thing, right? That's hanging over your head. You have to finish this by this time, otherwise X, Y, or Z is going to happen with the business. If the system already exists, maybe it's not the most performant, maybe it's not the nicest to use, maybe it doesn't scale super well, but it's working. It's doing a job, and that buys you some time. And then number 4 is the ability to compare when you write your microservices. So a little bit of analytics, basically. Is this microservice architecture working, scaling? Is the data throughput or latency better than it was before in the application, or is it all getting worse? Like, am I making such a distributed monolith that this is actually worse than it was before when it was just a monolith? And if you don't have an existing system, you have no metrics, so you don't know if you're making things better or worse as you go, right? There's 3 different approaches you can use when you're approaching a brownfield project. There's the Big Bang approach. This is the one where you get locked into a conference room with the team and you're not allowed out until the project is migrated. Maybe pizza is slipped in under the door or something like that, right? Mountain Dew. Evolutionary project, you can think of this as kind of a refactor, rebuild refactor cycles. So it's kind of like I'm going to take some endpoints out of the monolith and put them into a microservice, which is going to make things a little worse at first, but then I'm going to refactor it to make it work better. And then I'm going to bring some more out, and I'm going to make it worse at first, but then I'm going to refactor and make them better. So it's this like up and down, getting better, getting worse, getting better, getting worse, and hopefully moving towards a goal. That one is a bit better than the Big Bang approach, especially for a large application. But the best one, I think, is the Strangler Fig approach. Anybody heard of this Strangler Fig before? Okay, a couple people. There's this plant in, I think it's in Australia maybe, or New Zealand, that starts as a seed in the being dropped by a bird in a tree's branches. And it grows down the tree as a vine. Eventually, the vine reaches the ground and it starts sinking roots into the ground. It actually chokes out the tree's roots eventually. And now the tree dies, and all that foliage from the tree disappears because the tree is dead, but the vine is there. It has the access to the ground to get the nutrients and water it needs from there. It's now got access to the sun thanks to the dead tree branch being sort of like a backbone for it, right? So kind of a cruel plant, but a great architecture for gradually replacing things. So we can learn from nature in this case. So you imagine if you had like a large legacy application, you were trying to make microservices, you could put a facade layer, it could be like an API gateway type of an architecture in front of it, and then you could gradually move endpoints from the old legacy application into your new modern application, a little bit at a time. All the time you can keep that facade layer updated so that the applications that are actually using that are none the wiser, that anything is changing behind the scenes, hopefully, right, if you do it well. And then eventually you've moved everything from the legacy app over into the modern app. You can theoretically get rid of that facade layer. So that's a really great approach if you're trying to do a brownfield project with microservices. I have a whole talk that I'm doing. Brian and I are both traveling to a conference in Kansas City in a week and a half. Yeah, week and a half. And I have a whole talk about something from Microsoft called YARP, yet another reverse proxy that lets you, for .NET applications, lets you do gradual migrations using the Strangler Fig approach. Problem number 6, creating coupling through your cross-cutting concerns. This is a really easy mistake to make. A lot of teams who've built only monoliths will say, step one of a project is that some software architect has to make all the decisions about what tech stack we're going to use, what logging library we're going to use, what database we're going to use, whatever, right? One of the most common ones is that creates this coupling between modules is the logging. So if you imagine that your logging module belongs to maybe one team, but it's used by everybody, number one, that creates tech stack tie-in. All of those tech stacks probably have to be on the same, all of those services have to be on the same tech stack to be able to use that logging module, number one. That's kind of a problem for microservices. But number two, if somebody makes a mistake and deploys some new code that breaks the logging, or maybe they add a new feature to logging, but not all of the microservices have updated yet, and now the database for the logging and the logging code are out of sync between some of the different services, right? This creates coupling between all these different modules. And so even though it's really hard to think this way, when you're doing microservices, you want to actually think about these decisions as kind of separate decisions for separate teams, with a few exceptions, of course. If you have logging that's just all over the place, that makes it totally impossible to tell what's happening in your application, especially if you imagine the admin service that's creating a room, and then that room publishes an event to an event bus, and then that's subscribed to by 4 different things that do some update in their own database, and then maybe a user takes an action on that. How in the world, if each of those services has its own logging that's totally separate, how are you ever going to figure out what's going on in that application? So there's a bunch of services that exist out there, including this one I've highlighted called Seq, S-E-Q. That's basically a very microservices architecture friendly logging framework. What makes it friendly to microservices? Number one, it embraces the concept of eventual consistency. You can send it logs out of order. You can send it logs when it's not able to connect to the storage, underlying storage that it's supposed to use. It'll queue them up and then sync them later when it can. Number two, all of these different technologies, basically every tech stack that you've ever heard of is supported by Seq. So you could have one Java team, one Go team, one Python team, and one .NET team that are all working on totally different parts of the application, totally independent services, but they're all logging their events using Seq so that you can figure out what's happening in your application in one spot. Synchronous communication. So I mentioned a minute ago that this talk went onto YouTube recently, and a lot of people saw it. The number one most controversial thing that I said seems to be this one. And so I was telling Brian before the talk, over the last month or so since it's been out there, I went back just to make sure that I'm not crazy and that I'm not giving you all bad advice, and I haven't been giving bad advice for like 1.5 years at this talk. And I think what I discovered is that I'm giving good advice, and that the people who were arguing with me about this on YouTube comments are maybe just proof that what I'm talking about here is not very well understood, and that you can find a lot if you just start Googling microservices architecture. And if you Google communications between microservices, over half of the stuff that you find will be synchronous communication. I don't know why that is, because I can guarantee to you from personal experience that if you put synchronous communication in, you will regret it, because you will create a kind of coupling between your application, between your services that looks like this. So imagine you have an orders service and a customer service, okay? When an order comes in, the first thing you need to do is basically take the customer ID that comes in on that order request and look up the customer data, maybe get the mailing address or something, right? So you're going to get the mailing or shipping address for that customer. How a lot of synchronous communication-based microservices would do that is that I can't point with that, right here, they would start sending a request over, which basically blocks the orders endpoint or the orders service while that service is asking the customer service to look up a certain customer. Then the customer service returns a customer, and then the order service can go on. Now, this might work fine in some situations, but what happens when the customer service team decides to take that down on a weekend to do an update, or if they don't decide to do anything but someone trips over a wire or somebody does a bad code push and it breaks the customer service, now your order service is also broken for kind of a silly reason, which is that it just can't look up customers successfully anymore, right? Another thing happens though, and I told you that story at the beginning when I have the kind of funny slides with the nice organized server room and then the crazy wires from like Calcutta or something. The customer that actually came in had all synchronous communications between their microservices. So this is what we saw happening in their application. Whenever there was the slightest amount of load for any one of their services, and by the way, if you mapped out all their services with those red arrows I was showing you before, there was a red arrow from almost every service to almost every other service, okay? And that's what happens when you basically say the rule is you can call any service to get whatever data you want. Like you need data from almost everywhere. So you're going to be calling all these different services to get whatever data you need. What would happen is one and only one of their services would start to get a little bit overloaded. So maybe it would be the one that was, let's say it was like the order service in this case. It was the one that was getting the most use from customers. It would start to get a little busy, which would cause it to get a few milliseconds longer, just naturally, right? That happens when an application gets busy. It's not a big deal, except that made every other part of the application that was relying on it get a few milliseconds slower, which made third tier every other part of the application that was relying on those parts that was relying on that one part that was getting slower, which made every other part, and can you see what happened here? It was a domino effect. The whole application would get like a few milliseconds slower in one spot, and then boom, 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 the whole application would slow down. What was it slowing down for? Nothing. There was really nothing happening except the whole application was feverishly trying to communicate with itself between all these different microservices, which were not really microservices, right? What they really had done, obviously, is they built a monolith, but then they just made it really slow to have all, instead of having one chunk of code call another class through a procedure call, through instantiation, a procedure call, dependency injection, something like that. Instead, they had made that an HTTP request with all of the overhead that that has, which made it, orders of magnitude slower, which meant the whole application slowed down. So even though this was quite controversial on YouTube, I've kept it in here because I think it is still remains very true. If you allow yourself to go down this road, even though everything you'll find on Google is very likely to tell you that it's okay, I can tell you from experience it doesn't work well. Number 8, breaking changes to your events. So this is one of the hardest parts about microservices, in my opinion, is keeping your events consistent. So here's some rules that I found from a book that say, here's some rules that you can implement as a team that will help you know when to change an event and when to make a new event, because that's basically your two choices, right? When you define an event that says there's a hotel room change event and there's a hotel room added event, and then all of a sudden you're like, oh shoot, we just added a whole bunch of things to hotel rooms that didn't exist before. Some of the services are familiar with those, are going to be familiar with those, and some aren't. What should we do about it? Well, here's the rules that kind of help you decide what to do about that. Number 1 is that no new required fields ever get added to an event. Number 2, unrecognized fields when you're consuming an event, so when you're subscribing to an event, any unrecognized fields are just ignored but forwarded. So that basically means that if something else is going to know what to do with that data, you should keep it moving forward, right? But ignore it if you don't know what to do with it. Number 3 is that consumers of optional fields use default values when those values are missing. So if somehow an event gets published by a service that doesn't know about some new field, then everybody that consumes that needs to have some default that they should assume for those, right? So new a hotel room, maybe there's like a status on the hotel room and there's like a new status, and that's going to be the default status for our hotel rooms if we don't know. And then number 4 is that if you can't satisfy number 1 through 3, then you have to create a new event. So you might have a new hotel room B, or new hotel room prime or something like that. Basically a new event that communicates the same type of thing, but now you have a service that has, when a new hotel room gets created, it has to publish a new hotel room, like original recipe event, and it has to publish the new prime event or the new B event as well. So that's kind of the rules that we use when we're doing that to make sure that we don't break things, because that can create coupling between your services as well. Number 9 is not automating build and release. Hopefully, I shouldn't have to say this as much anymore, but still encounter clients that don't have CI/CD automated or any kind of DevOps in their organization. Sometimes they're even big organizations that don't have this, which is really surprising to me. But I always tell them that having an automated build and release pipeline is a prerequisite to doing microservices. Microservices are all about doing quick releases, doing lots of different releases to lots of different endpoints. Super, super prone to human error if you're doing it manually, right? Even if you have an application with only 6 microservices, that's 6 different places you could accidentally deploy the wrong application to, not to mention all the different copies of the environment, dev, staging, testing, whatever, in addition to prod. And it gets just super, super time consuming if it's not automated. So that's always a prerequisite that I recommend. Number 10, our last one, something I alluded to in my earliest definition that we talked about tonight of microservices, which is having teams that don't match the microservices model. There's this law called Conway's Law that says that, to quote it here, an organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. Paraphrasing, what does that mean? That means that any human organization that creates something is going to create something that looks an awful lot like their org chart for that organization. The example that's always given, it's kind of an old-fashioned example, but if you give 4 different teams the job of creating a compiler, you'll end up with a 4-pass compiler, right? There's no team that's going to say, oh, the work that we did is not important, and we just bow out. Let's go ahead and have the 3 people or the 3 groups that did the other parts be the only part that actually makes it to the end. Every group is going to say, well, our part's important too, and even though maybe there's some overlap in there. So if you don't want a 4-pass compiler, you shouldn't start with 4 separate teams working on the compiler, right? Now, the same thing applies to microservices. If you have a small team, maybe 5 developers, 10 developers, something like that, they're typically all working on the same thing or maybe a couple things at the same time. And you want to suddenly do a microservices architecture, I would say take a pause and ask yourself whether that really makes sense or not. Because the whole point of microservices architecture is doing these many, many deployments independently from each other. And if it's all the same people doing it, it starts to make you wonder, like, do you really need that, right? If you're Amazon and you have tens of thousands of people that are touching the Amazon.com website in some capacity, yeah, that makes sense. You can't organize 10,000 people to do something efficiently as a single team. So it makes sense to subdivide that somewhat. But if you have 10 people and you're editing maybe 4 or 5 modules, that doesn't make as much sense. This does make more sense, which is not to say that if you have 5 modules, you have to have 5 teams. I've seen it before work really well when there's 5 modules, but 2 of them are a bit smaller, and so they belong to one team, and then the others are one-to-one. But if you don't have something like this, then maybe microservices aren't the right fit for your needs. All right, so that's my 10 reasons. Before I kind of sum up again, I'll mention Beer City Code shamelessly one more time. If you want to come join us there, there's a workshop day, including a microservices talk on a Friday. So if you want to learn more about how to build microservices, there's a microservices talk or workshop that's like 6-hour long thing that day. And then there's lots of talks that are about microservices in our breakout sessions on Saturday too. So we talked about how monoliths can be good. We talked about how microservices should really only be done if you have a really good reason to do it, not if you just have well, it's the cool new architecture and I wanted to try it. But if you have a good reason for it. We also talked about if you're trying to build something that is easy to build and is for a small team, that probably Monolith is going to be better for you. If you have a huge team that you need to subdivide and you want to be able to do lots of updates to that application, then microservices might be right. Finally, it's that those 10 tips that I just gave you. If you do end up building microservices, just be careful to avoid those. Or if you already started building microservices and you made some of those mistakes, maybe now is a good time to circle back and look at some of those. This is my information again. If you want to download the slides there on my GitHub, feel free to reach out if you have any questions. But I will take questions now in person for anybody here. Yes?
So, do you have any advice on how you manage those events? Like, just because you have the event bus and you have events, I'm on the reservations team. How do I know that there is the new prime event and I need to care about that? And same way that you might have some of those mishaps just with a traditional style.
Yep. Great question. So just to repeat it for the recording, it's basically how do you orchestrate communication between the different teams, particularly when it comes to the events, right? Because that's where they really actually should integrate. So I think of the events as almost being like APIs. So if you're a company that's producing APIs for other people to consume, maybe your customers to consume, what do you normally do? You create documentation for it, right? So that's one thing, is creating documentation that says this service is going to publish these types of events. Then you have to live up to your documentation, though. Just like if you create a public API, you can't just go around breaking it all the time. You have to keep that version alive, if not indefinitely, at least for a certain number of years. You have to send out lots and lots of emails if you're going to break it and shut down that version of it, right? So that's number one. Another thing I've seen work well in an organization that's using this architecture is having almost like a event committee where like a team lead or an architect from each project, from each service, comes together and talks about, on some sort of regular basis, talks about the events that they have and what other events they'd like to have. And our team just published this new event, and oh, we'd like to use that. What does it have in it? And oh, you're still working on it? Could you add this to it? That type of thing. I've seen that work pretty well. Yep. Does that answer your question?
Yeah.
Good. Other questions?
So since we're at the West Michigan Azure user,
yeah,
do you see microservices deployed to Azure frequently? Part one. Part two, if so, what kind of resources do you see that deployed the most?
Yeah.
Part three.
Oh, three-part question. I guess when you're in charge, you can ask however many you want, right?
Which ones do you see successful?
Okay. So let me see if I can remember all three parts of that. So Azure, do I see microservices deployed to Azure? If so, what types of resources are being used for them? And then what are the most successful? Is that right? What's great about microservices architecture is that it's not really picky about the technologies that you're using. So I'm sure everybody knows about containerization like Docker, and then orchestration with things like Kubernetes. That's a very popular way to do microservices that you can obviously do in Azure. There's actually maybe too many ways to do Kubernetes in Azure, if anything. But that's a very popular way, which also allows you to then very easily do it on premises, very easily do it in AWS as well, or Google, or wherever else you want to do it, because Docker is kind of ubiquitous, right? Another set of technologies that I've seen, and by the way, those I've seen be very successful. That's a totally legitimate technology stack to choose. Another that I've seen be very successful is kind of the serverless architecture. So in Azure, that would be Azure Functions. AWS, it would be Lambda. Those also make a really good fit. So if you're more familiar with containers, or if you're more familiar with virtual machines, you can go and set up virtual machines with web servers and do all of that stuff as well. Obviously, it's just a little bit more infrastructure work, but that also I've seen be successful. So I think that at the high level, what my answer is it depends on what your needs are as an organization. If you have a bunch of people that know how to do Apache or IIS or app services in Azure or something like that, then that can be a totally legitimate way to do it. If you want to get rid of people having to think about that stuff, then serverless is a great choice. And if you want to kind of go in the middle of the road, but also be maybe multi-cloud or something like that, then containers is a pretty good choice. So, does that answer the question? The questions? Good. Other questions? Cool. Well, thank you very much, everybody. Yeah.